Hi there, welcome to your lesson on measures of central tendency. Very important part of statistics. Let's get rolling. Let's begin here with this question. When faced with lots of numbers, how do you know which average is best to use? So this is the central question of measures of central tendency. Measures of central tendency are all about finding what is a number that can represent like the average or middle of your data set. So let's look at that. Measures of central tendency tell us where the middle of a set of data lies. So there are several different ways to describe the middle of data, and we're going to talk about which is better and when. For example, you may know these three basic measures of central tendency. They are mean, median, and mode. You can see these two graphs here. This one here is very symmetrical. So imagine data where you had just a little bit of, imagine this represented, for example, heights of people, right? This graph here shows that very few people are on the low end of the heights scale, and very few people are super tall. Most people are somewhere in these middle range of heights, let's say. So if we were to find the mean, which we know is called the average of this set of data, the mean would be somewhere in the middle here. Also, the median would be and the mode would be also. We'll talk about what these three are and how different they are from each other in a moment. But here you can see mean, median, and mode are in the same place when the data is symmetrical. But if the data is not so symmetrical, for example, here we have kind of more people going to the tall end if we're talking about heights still, right? Then the mean moves in that direction, right? Since there's more people on the taller end, they pull the mean up and the mean moves here. Whereas these other two measures of central tendency, mode and median, they kind of are left behind here. We'll talk more about that as we progress through this lesson. For now, know again that measures of central tendency tell us about the middle of a data set, and the three main types are these three here. Let's take a closer look now. So let's say, again, the question is, when you're faced with lots of numbers, how do you know which average is best to use? So let's try those three main types of averages or measures of central tendency on this data set here. Let's say we are given the ages of children in a family. So you can see there's all kinds of ages of children. 5 children, they all have a very big spread of ages here. Okay, let's look at mean first. The mean of a data set is the sum of all values divided by the number of values in the set. And that is typically what we know as average. Although here in this opening sentence, average seems to imply that all the ways to measure the center of data can be called an average, even though the mean is the one we typically associate with an average. Okay, so by the definition of a mean, we are going to add the 5 values right here. We're adding them up and dividing by the number of values, which is 5. It tells us our mean will be 8.6. The average age of these 5 kids is 8.6. And notice we use the symbol X with the little line over it. This is called X bar. That is typically used to represent the mean. All right. So you know, and don't be afraid by all these mathematical symbols here, but for a discrete data set, which this is a discrete data set, we can use this formula to find the mean. Okay, we found the mean like this, right? We know that. Add them up, divide by the number of things. That's easy. But that's all that this formula represents. Don't be, again, don't be scared off by these things here. Let's look at it together. This symbol here, this giant thing that looks kind of like an E, is actually a Greek letter sigma, which means sum. So this means the sum of all the values, and see here we have x sub I, and here it says I equals 1 to n. That means that if we put 1 in here, and then 2 in here, 3 in here, it's like saying data value, data point 1, data point 2, data point 3, and so on. So you take the sum of all the data points, that's what this part represents, and then you multiply by 1 over n, which is the same as saying divided by n, which is the number of data points. So all that this means is the same thing we're used to doing when we find the average. But it's good to sometimes put the mathematical symbols behind the processes we use, especially later when you write your mathematical paper or exploration in this course. It's good to know how to write things in the proper notation. All right, next, let's look at the median. Median is another common way to find an average or a middle of a data set. And the median is the middle value. It literally means the middle value in a data set. To find the position of the median, we're going to use this formula. The median position is found by doing n plus 1 divided by 2. That means the number of data points in a data set plus 1 divided by 2. In our case, there are 5 data points, so 5 plus 1 divided by 2 gives us 3. Now, don't think that this formula gives you the median. 3 is not the median. 3 is definitely not the middle value in this data set, right? This is the position of the median. So if you look at your data set, this is position 1, position 2, position 3. This tells us that the median is at position 3. So again, here's our data set. Here's position 3. That is the median value. Our median in this data set is 8, and that makes sense. That is the middle value of this data set. Finally, we have the mode. The mode is the most frequently occurring data value in the data set. In this data set, no value repeats. Therefore, you cannot say that 1 is the most frequently occurring. In this case, for this data set, there are no repeating values. Therefore, this data has no mode. That should say no mode. All right, let's try this one. The grades in a history test for 14 students were as follows. Here they are. Find the mode, median, and mean. Okay, and then we'll try B after that. Concentrate on just finding the 3 measures of central tendency first. And it often helps to take the data and sort it in order least to greatest first. So I will do that for you here. Here's our data written least to greatest. Now go ahead and find the mode, median, and mean. All right, let's see how you did. The mode is 58. You can see 58 occurs 3 times. It is the most occurring number, and that's the mode. Okay, so is mode a good representation of the middle of this data set? Not necessarily. Just because 58 occurs most often here, it still doesn't seem to really acknowledge what the real center is. So mode is not always a perfect way of representing the center. The median is 66.5. Why? Again, if we use the median position formula, n plus 1 over 2, here we have 14 pieces of data. So 14 plus 1 over 2 is 7.5. So again, that tells us at position 7.5, which you can see here when the data is written like this, 7.5 is right between these 2 in red here, because this is 1, 2, 3, 4, 5, 6, 7. Here's 8, so 7.5 would be in the middle here. That's where the median will be. And whenever you're caught between 2 numbers, the median is the average of those 2 numbers. And in this case, the middle number, or the average between 66 and 67, is 66.5. All right, finally, the mean. Of course, you can add up all the values, divide by the number of values, 14, and you get 66. So we have these 3 measures that show us something about the center of this data. They're all different, although the median and mean are quite close to each other. And that tells us, well, maybe we can say the center of the data is somewhere around 66. The 58 seems to tell a different story. All right, now how do you do this on your calculator? Okay, it is really important that you know how to do this on your calculator, so grab your calculator, here's one, and here's how we always deal with statistics on our calculator. We begin by pressing the Stat button for statistics. In there, you enter this menu. Number 1, Edit, is where we usually begin. Edit is where you enter your lists of data. So I'm going to press number 1, and now I have some kind of data set there already. I'm going to clear it out. If you do happen to have some data in there already, here's how you clear it. Go up to highlight the list name here, press clear, and then enter, and it clears the whole list. Okay, now I'm going to enter this full list of data here. It doesn't matter if you enter it in order like we reordered here. You can order it in random order like this. So I'll do that now. 58, enter, 67. Please go ahead and do that with yours as well. Okay, as you can see, I finished it off here. Now that I have my list entered, you need to be able to calculate these single variable statistics, mode, median, mean. These are all called single variable statistics. They are statistics about a univariate data set, right? So let's try it out. Here's how you do it. Press Stat again. And now instead of Edit, and that's where we enter data, we're going to go to Calc. To get to Calc, we have to use the arrow. I'm at Calc. And now I want one variable statistics. That means basically univariate statistics. Enter. All right. It's asking where are we taking that data from, where we only entered data in one list, which was list 1. So that part's okay. We don't have a frequency list. We'll talk about that later. And calculate. Enter. All right, it calculated things for us. X bar, we know X bar means mean. It says the mean is 66. Great, that matches what we have here. Let's see, I'm going to go down the list here. I'm going to press arrow to go down a little bit. It tells us our median here. Okay, median is 66.5, matches what we have. Great. And mode, just so you know, mode will not appear in here. It doesn't have mode in here. So mean and median are, but mode is not. Okay, that's how you calculate things on your calculator. Let's look at question B. It says a 15th student took the test and the mean became 66.2. Calculate the grade for the 15th student. So you're adding one more data point, but you don't know what it is. And then you want to figure out the new average. Or sorry, you know the new average. It changed. It went from 66 down to up to 66.2. So the average went up slightly. So you know the student scored something above the average in order to raise it up. But what did they score? Here's how we can do it. We set up our average formula, which is adding all the data values divided by the number of data values, right? So here again, I'm writing out like showing that we're adding all these. I put ... here to save some time. And at the end, I added plus X, that unknown new test result for student 15. And then I'm dividing by 15. And we know the result of that average calculation will be 66.2. That was given to us. So now we have an algebraic equation we can solve. You can begin by multiplying by 15 on both sides, and you get this. And then I also, at the same time, combined all those numbers on top and wrote plus X because we don't know X. So X plus the result of all that, which is this. And you're one step away from getting X. Subtract 924 from both sides, and you get this. So it tells you the new student must have scored a 69 on this test in order for their average to go up slightly like that. All right, kind of a classic kind of problem there to check your understanding for mean. Let's move on. Let's say we have these two situations. Mindy opens some bags of candy and counts how many pieces are in each bag. So she finds that there are from 23 to 27 pieces in each bag of candy. 2 bags have 23 candies, 3 bags have 24 candies, 9 bags have 25 candies, and onwards here. So that is a frequency table. Now, second example here is we have the weights of 50 cats, and they're recorded in this table. And now we know weights, again, this was a discrete variable, right? The number of candies is discrete, so we present it this way. And the weights, we know weight is a continuous variable, so therefore we'll present it this way, right? The weights can be of, this is of cats, yeah? Weights of cats, okay. So some cats are between 2 and 3 kilograms, some are between 3 and 4, 4 and 5, and so on. Notice here it's saying including 2 and up to 3, but not including 3. Here's including 3 and up to 4, but not including 4, and so on. You can see most cats tend to be right here, between 3 and 4 and 4 and 5 kilograms right here. Okay, again, our goal here is to find the mean, median, and mode. And sometimes students get confused by these kinds of frequency tables when they have to find mean, median, mode. For example, somebody may take these here, add them up, and divide by 5 to find the mean. But that would not be correct. These are not all your possibilities. You have to think about, what does my data set look like? If I wrote this out as a full data set, what would it be? In this case, here, for the candies, the data set would look something like this. I put ... because I didn't write the whole thing, but it begins with 23, 23, 24, 24, 24. Why? There's 2 bags that have 23, so 23 appears twice in our data set. 24 appears 3 times in our data set. 25 9 times, and so on. So that's what our data set really looks like. So don't make the mistake of just adding those up and dividing by 5 to find the mean. That's not right. But this would be a lot of adding and dividing to get the mean. So definitely our calculator will be more useful here. And for the second data set, we're going to do the same thing. Now be careful how you look at this. When you have continuous data like this, here we had a specific value. 23 occurs 2 times. That's easy. But here it's like, okay, some weight between 2 and 3 occurs 5 times. So we don't know what that weight is. It could be 2.1 occurs once, and maybe 2.3 occurs twice, and maybe 2.7. We don't know. We just know there's 5 weights between those values. So what we do is we're going to find an approximation of the mean. We're not going to find the actual mean. We're going to find an approximation. And we approximate it by saying, well, we know the range here. So why don't we just go right in the middle, which is 2.5, and say we have 2.5 occurring 5 times. And continuing with this data set, we could write that some weight, so 19 times cats, 19 weights of cats lie between 3 and 4. So there's 19 cats with weights somewhere between 3 and 4. But again, we don't know what all those exact weights are, so we just say, hey, let's just assume they're all right in the middle, 3.5, and we have 19 data points of 3.5. Well, it could take forever to write that out, but I'm showing this only so that you remember that you have more data points than you seem to see here, right? There's actually this many data points if you add all those up, or this many here. Okay, so now let's find the mean. To find the mean here, you can just do 23 times 2 plus 24 times 3 plus all that, and then divide by the total number, which is all these. Try that now. Okay, so here's the calculation for that one. Again, 23 times 2 plus 24 times 3 plus 25 times 9, because that happens 9 times, and so on and so on. And if you add all these up, your total count is this, which is actually, looks like 20. So, and the average then works out to 25. Okay, how about the median and the mode? Well, without using our stat feature in our calculator, we can find the median and mode. The median is the middle value, remember? And we can begin by doing number of data points plus 1 divided by 2 to get the position, right? So 20 plus 1 over 2 is 10.5. So you're looking at this data set and you're like, if I went to position number 10.5, so yes, you could have the whole data list written here or just go in the table. In the table, well, here's 2 data points. And if you go to here, there's 3 more data points. So I'm 5 data points into the data set here. And if I go to here, I'm now 14 data points. And I only need to get 10.5 into the data set. So that means the median is this value here, because that already brings me into data up. If I finished here, it would be data point 14, but I only need to get to number 10.5, which tells us then the median is 25. All right, how about the mode? Is there one of these numbers that appears most frequently? Well, we can clearly see that in the frequency, and 25 occurs most frequently. Therefore, the mode is 25. All right, now let's try that here. Okay. Oh, no, before that, let's do this on the calculator then. So how can we make this process a little quicker on the calculator? Let me show you. So here's the calculator again. I'm going to open this up. And just like we did before when we entered data, we can enter data with these 2 columns, including a frequency column to help us. So I'm going to do clear here. Okay, stat. Go to edit. You want to clear the list you had from before. Go up to the list name and then hit clear and then enter. Now your list is clear. Now I'm going to enter in exactly what I see here. 23, 24, and onwards. Okay, and then just so you know, in list 2, I didn't finish that one, but in list 2, you're going to enter your frequencies, okay? So 2 and 3 and so on and so forth. Please do that. Okay, I finished it here. Hopefully you have the same. You're going to press stat again, and just as before, we're going to arrow over to calc, 1 variable stats, number 1, and this time we have list 1 as our data, and our frequency list is list 2. So how you're going to enter that is second, and above the number 2, you can see a little blue L2, so that list 2. So now it knows it's going to use this table, including these frequencies, when calculating things. Calculate, and now let's check. Hey, mean is 25. That matches ours. Go down the list. Median, 25 also matches what we had here. Okay, so now let's try the same thing with this one, our continuous data set. Using your calculator, the same way we just did, enter these 2 lists. Enter this as list 1, this one is list 2. But again, when we were looking at this, we said we don't have an exact value here. We have a range of values. So why don't we just enter that middle value like we did here? So when you're entering list 1, this would be 2.5. This would be 3.5. You always go with the middle value, 4.5, 5.5, and on, and calculate the mean, median, and mode. Let's see what you get. Okay, in this case, the mean should be 4.2. Double check that you got that to work out. The median, if I did the process of looking at this or doing the position, 50 plus 1 over 2 is 25.5. So at position 25.5 in this data table, let's see, here's 5. Here's 19 more data points, that's 24. So I need to go a little further. So I know the 25th data point is going to be here, which means 4.5. You can see it here. And that's the same value you'll get from your calculator. And now your mode, well, in this case, we were able to say the mode was 25. In this case, you're like, well, which one occurs most frequently? This range of values. So what we do is we don't say the mode is 4.5. We say that this whole category here is called the modal class. And we enter it like this. And I think I made an error here. There should not be an equal here. All right, a couple more problems for you to try. Looking at both these data sets, state the mode. Just by looking at the data, you should be able to state the mode. And then use technology to calculate the mean and the median as we have. Try them out. Okay, check your answers. First one, mode, mean, median. And second one, mode, mean, median. And now, a second follow-up question to that. Comment on the effect of the outliers on the mean and median. So if you look at both data sets, they kind of have some outliers. For example, in the first data set, you can see the values are pretty consistent, not too far off of each other until the last three, which are kind of way off. And these are what number of ice creams sold. So for some reason in these last weeks, there was much more sold. Those are kind of outliers. And then notice what they did to the mean. Notice the mode and median stayed at 158, whereas the mean was much higher. Why? Comment on that. And then look at the second data set as well in the same way. So for A, the three large values raise the mean, but the median remains lower as it is just the middle value in the data set, right? Doesn't matter. These numbers could be in the thousands. The median would be unaffected because the median still tells you just what is the middle value. It doesn't matter how big the numbers at each end are. It just matters what position you're looking at. All right, so for B, how about for B? For B, we can say the modal value of 2. You can see there's a mode of 2 here. There's many occurrences of 2. And that value pulls down the mean. The average is really affected by that low score there, right? So the average goes down. Where's the average? The mean is 5.82, but the median remains high because there's still many values above there, right? It's still the middle value, whereas this here really affected the mean. All right, just to finally summarize everything related to that, we began by talking about measures of central tendency as being measures of the average of a data set. And we said we're looking for the middle of a data set. That's kind of like our average. And we can describe that three ways: mean, median, mode. We're coming back to the same graph we saw in the beginning. And basically what we just saw in this example here, when you have outliers, for example, this data set here has some outliers on this end. Those outliers affect the mean, but not the median, for example, right? So the mean here is pulled up by these outliers, but the median is not pulled up as much because the median is just the middle value. Whereas here in the symmetrical data, mean, median, mode are all identical. Final question, we have the ages of 15 cats here. They're already sorted for you. Find the mean, median, mode, and then comment on whether there are any points that distort the calculation of the mean. So do you think any of these will really have a huge effect on the mean? Which points are those? And then remove the values you think that will really affect the mean and recalculate the mean and see what happened. All right, here's the answers here. When you kept the full data set, your median is 12, mean is 13.6, and mode is 12. Looking at the data set, well, first of all, you notice the mean is higher than median and mode. So here, these last two values, 24 and 25, are kind of outliers. They pulled up the mean, but the median and mode remained in the middle. So notice the mean tells a different story than the other two. So in that case, you can remove those two, which might be outliers. And there, when they are removed, the mean then becomes 11.9, which is pretty much on par with the median and the mode. All right, hope that brought those ideas clear to you, and be ready to engage more with this soon. See you soon. Bye.